Hey everyone, welcome! So, when you're writing code, you're constantly making stuff, right? Numbers, text, all these complex objects. But have you ever really stopped to think about where all that stuff goes? Like, where does it actually live inside your computer's memory? Well, it turns out it's not just one big messy drawer. It's actually a tale of two completely different systems.
Yeah, it sounds like a simple question, right? But the answer is, well, it's pretty fascinating. And honestly, it's fundamental to writing really good code. See, it's not just one big box where you throw everything. Where your program decides to keep its information has a huge impact on its speed, how efficient it is, and even how stable it is.
Because you see, a program's memory is basically split into two distinct worlds. Each one has its own set of rules, its own, let's call it a personality, and its own specific job. We call them the stack and the heap. And seriously, understanding how these two work together, that's like a developer superpower.
Okay, so let's start with a really quick high-level comparison. Think of the stack as the place for all the quick, short-term jobs. It's ridiculously fast and super organized. The heap, on the other hand, that's the giant warehouse for the bigger, more permanent things. It's way more flexible, but yeah, it takes a little more effort to manage. Just keep those two ideas in your head. Fast and temporary versus big and long-term. Now, let's dive in.
All right, first up, the stack.
The name itself is a pretty big clue, right? You should literally picture a stack of plates. It's all about order, precision, and most importantly, speed. This is honestly the perfect way to think about it. The stack is like this super fast, incredibly meticulous personal assistant for your code. It handles all the immediate tasks with lightning speed, and here's the best part. The second a task is done, it cleans everything up, all by itself. No fuss, no mess, just pure, beautiful efficiency. So how does this amazing assistant actually work? Well, whenever your code calls a method, the stack instantly carves out a little block of memory for all its local variables. It stacks these blocks one on top of the other, following a really strict rule. Last in, first out, or LIFO. The last method that gets called is the very first one to finish up and get removed, and that is the secret to its speed. As soon as that method is done, poof, that memory is gone, cleared automatically. It's so fast because everything is so predictable. Okay, so what kind of data gets this VIP, high-speed treatment? We call them value types. And these are basically variables where the actual value, the data itself, is stored directly in that little block of memory right there on the stack. And we're talking about the simple, fundamental building blocks of your code here. You know, things like numbers, your ints, longs, and floats, or single characters, and simple true-false bools. Because they're small and have a known fixed size, they are just perfect for the stack's super organized system. But of course, there's always a trade-off. Our super fast assistant, well, they have a pretty small desk. The stack has a very limited amount of memory, and that's why you sometimes run into that dreaded stack overflow error. You've literally tried to pile too much on it. So it's fantastic for temporary variables, but it is not the place for big data or for any data that needs to stick around for a while. For that, we need to visit the other world. So now, let's explore that other world. Welcome to the heap. If the stack is a neat and tidy office desk, the heap is a massive, sprawling warehouse. This place is all about size, flexibility, and long-term storage. You can think of this manager as someone who can handle anything you throw at them, no matter how big or complex. It finds space for your data, but it's not instantaneous like the stack. It's a bit more deliberate, and it needs a special cleanup crew to keep things tidy. So the process for the heap is totally different. When you use that new keyword to create an object, you're basically telling the program, hey, go find some space in that giant warehouse for this new thing. The program goes and allocates the memory on the heap, but then it places a little note, like an address or a reference, back on our fast stack. And the cleanup? Nope, not automatic. A process called the garbage collector has to periodically sweep through the heap, find all the objects that nobody's using anymore, and then free up that space. And this brings us to the other key concept. The data on the heap are called reference types. The variable itself, which remember lives on the fast stack, doesn't actually hold the data. It just holds the address of where to find the real, potentially huge object over in the heap. So what kind of stuff lives on the heap? Well, think about all the more complex or dynamic data. Things like text strings, lists of items inside arrays, or any custom objects you build from classes. Basically, if its size can change or if it needs to exist for longer than a single function call, it belongs on the heap.
So we have the fast, orderly stack and the big, flexible heap. They might sound like total opposites, but the real magic, the whole point of this, is seeing how they work together. They're not separate entities, they're a team.
Let's look at a super simple line of code. When you declare an integer like this, int price equals 5,000, that's a value type. So the variable price and its value, 5,000, are both created and stored directly on the stack. It's simple, fast, and totally self-contained.
Okay, but now, look at this line. Package podge equals a new package. We're creating a new package object. Because this is a class, it's a reference type. That new keyword is our signal to the system to go build the actual object over in the giant heap warehouse. Then, a tiny little reference, just an address, gets stored in the podge variable, which lives back on the superfast stack. And this is where it all clicks. Just look at this map. On the left, we've got our fast organized stack. The price variable is right there, holding its value, 5,000, directly. Simple. But below it, the package variable doesn't hold the package object itself, right? It just holds a pointer, an arrow, that points to an address. And that address leads us over to the heap on the right, where the actual, much larger object with all its data actually lives. This is the fundamental partnership between the stack and the heap.
Okay, that's all pretty cool, but why does this actually matter? Why should you, as a developer, care about all this behind-the-scenes stuff? Well, because knowing this is the difference between writing code that just works and writing code that works really, really well.
For one, understanding this whole thing helps you optimize your code for performance. You can start making conscious decisions, like maybe using a struct, a value type, instead of a class, a reference type, for small bits of data to keep it all on the fast stack. You'll get so much better at managing memory, avoiding creating a bunch of unnecessary objects on the heap that the garbage collector has to constantly clean up. And really, it just helps you write cleaner, more efficient, and way less buggy code right from the start.
So what's the big takeaway? It means you're not coding in the dark anymore. You now know the secrets, the tale of the two systems, the fast assistant on one side and the powerful warehouse manager on the other. You get how they work together. So the only question left is, now that you know, how are you going to use this knowledge to build better, faster, and smarter applications?